All right. Good morning, everybody. Today is September 13, 2024. This is the second Friday meeting of the OHDSI Phenotype Development Evaluation Workgroup. We meet twice a month, on the second Friday and the fourth Friday of every month. I sent out the agenda for today's call, advance of this meeting. The agenda, which I'm going to share on the screen right now, is to talk about new topics, which is ongoing topics, which is the upcoming OHDSI Symposium. So we have our face-to-face meeting at the OHDSI Symposium. We have a three-hour slot. So we need to talk about the attendees that are coming and also the finalize the agenda. So Aza and I have some ideas. We have been talking about agenda topics for the last several meetings, and I think we just need to finalize it and post it. That's one topic that I would like to propose. The second one is a scientific discussion. So one of our OKRs for the year is to deliver on scientific innovation. So one of the topics is that has been discussed before is this idea of phenotype stability. So we have that topic that's a small group of us has been working on it diligently. So we can talk about that. The other topic is the dermatomyositis study that Dr. Ms. Micali is leading. So I want to see if there's any update on that. So those are the topics that I can think of. Jamie, do you want to give any updates on measurement errors or any other topics?
I do, but put me near the end so I can draw this last plot before I show it to you.
Okay, great.
And then and then we can give a quick update. I see Jackie is not here.
Oh, I'm here.
Oh, he's here.
Sorry,
okay.
it's a little late.
And Jackie can give an update on the Cipher integration.
Yeah, hi. Sorry, I didn't post to the work group page. It seemed to block me and think I was spamming it. But yeah, just a brief update. So we met yesterday to finalize our abstract for the Immunoinformatics Summit, which is due next week, and I think we're getting very close to having that finalized. And also, we are just reviewing the initial integration of OHDSI phenotypes into Cipher and plan to finalize our test with a total of around 25 of them. So once that we review that on our test site, we'll push to production, and I can share the links with this group for you all to see.
Perfect. And maybe, Jackie, once the abstract is finalized, maybe we can put it in the folders, or maybe Gautami can put it in the folders of the work group so everybody can read it.
Is that okay with you, Jackie? Because you're the lead on it.
Oh yeah, that sounds good.
Perfect.
And maybe Gautam also put on our just communication once we confirm that those 25 are fine, and maybe you have a plan of how to basically upload get more of the phenotypes to Cipher. We can make a announcement in the OHDSI community call, so people who are in the VA side know that the OHDSI phenotypes are now also available in their system.
Jackie, would you be comfortable attending an OHDSI community call and making an announcement of that effect once the 25 phenotypes have been integrated?
Yeah, happy to do that.
Perfect. Perfect. Awesome. Thank you so much. I really look forward to this ongoing collaboration with the VA Cipher. I think VA Cipher is providing an opportunity for the various libraries to have a home, and just like the National Library of Medicine provides a home for concept sets like SNOMED codes, I'm looking forward to the VA Cipher hosting code definitions for reuse. The other topic is the main topic of the day, which is the Global Symposium. So we had talked about of several ideas before. Azad, you had written up.
Yeah, I did. So if you get back to the, I proposed an agenda, and maybe today we can just look at it and get feedback. I put it in the Teams, so in our main page.
Okay.
If you navigate out to the just the general posts, yep. Here we go.
There.
Yeah. So a 3-hour in-person meeting. So there'll be some people that might be attending that usually attend this call, and then there might be usually we also have like people who are just happen to be in the symposium and interested in the topic who also join. So it's not necessarily only our people who have been active, but also new people. So what I and Gautam are proposing is basically to use the 3 hours to recap or understand where we are in terms of our OKRs, and in that and based on that, give a more deep dive discussions and update on the progress we made. So if you guys remember our OKRs, we really focused on kind of 2 topics. One is the methods and development of methods, and on that, Jamie leading the work on measurement error and how to integrate it into study estimates, particularly incidence rate. And on the method part, we also have the thing that Gautam and I has been focusing on of how to get objective diagnostics for phenotypes. When somebody wants to evaluate the phenotype using real-world data. And then the second topic is just the community outreach and how we can get the library to reach out for people to use the library, and also how to add and contribute to the library. And on that's why we got interested in Cipher, of course, because that's hardcore in our goal of getting visibility to the library and getting it to users, which the VA Cipher create a great opportunity. And the second is running network studies, which what Dr. Micali has been leading with the dermatomyositis, I can't say it, example. So those are the main things that we feel that this year we made progress on, and we would like to use the symposium time to do a deep dive, make a progress, make sure that we communicate what we do, so we have a good understanding of where what went well, what didn't go well, and that can help us in a discussion, which we will use at the end of that time together to think about next year and what we need to maybe focus on or not focus on, and so forth. So that's why I'm proposing the following structure. We start with 10 minutes just orienting everybody to what our OKRs at the beginning of the year, and what's the mission of the group and why we're together, and all those high-level kind of introduction, especially for people who are not part of the group already, who might attend. Then we talk about 2 method updates. Sorry, I did not talk about probabilistic phenotyping that Jill is leading. So Jill can give us a 20 minutes deep dive into where is the thinking with probabilistic phenotyping and the progress he made. And then also Jamie can give us a 20-minute deep dive into the integration of measurement errors into study estimates and where he is and where he needs support. So those are 2 method topics. Then we talk a little bit about promoting the library, and we hear from Jackie about exactly what happened in Cipher integration and where she needs support and what's the next steps. And then we hear from Dr. Micali about the dermatomyositis network study. The results, hopefully by then we actually have the results, and we can talk about the topic in depth and what we learned from the network about the phenotype, and so forth. So we have maybe by then the finalized results. I'm not sure, but maybe. And then the last method topic is Gautam and I want to talk, not talk, because we're going to talk about the diagnostic, what we've been talking about working on, but we're hoping to use some time to actually run more of an experiment during our time together. So you'll hear today that we've been working on, just like similar to study diagnostics and the data diagnostics that the OHDSI community has been working on, we've been working on objective diagnostics for phenotypes, but using statistical methods and so forth. We made some progress on one element, which is the stability of the phenotype. The second element is the consistency of the incidence rates that we produce using these phenotypes across data sources. And so based on that statistics, we want to have kind of a fail-pass diagnostic for a phenotype in a data source. By then, we will have produced that statistics, but we think that the symposium time will be a good time to actually do an experiment where we have human eye to look at the results and kind of validate or devalidate or disagree with the results. So what we could do is we can have a set of phenotypes from the Phenotype Library, and we will have the algorithm that Gautam and I and Marta and Patrick has been working on to say this is a phenotype that fails versus this is a phenotype that pass in a data source. And then we can split into groups and review, do we agree with the algorithm or we don't disagree as humans? And based on that, we basically either validate or like have an idea of how well our diagnostic is working. So it's more of a workshop where we actually have hands-on, use an hour where we split into groups, look at the results of the algorithm, and basically rate if we agree or disagree that the phenotype is truly like a failure or pass.
Yeah, which could
yep.
which
And
could
then
be a scientific paper.
Which of course we will that part will be used to write up those methods and how we validate them using a human review, which we'll write up. Yeah, and then use the last hour to talk about next year. So it's a long, maybe ambitious agenda, but yeah, want to hear back if you guys feel that this is a good use of our time, or too much or too little.
Yeah, the only thing I'd comment on is that the first, besides the last two bullet points there, the first two add up. The first set adds up to 90 minutes, not an hour. So you got 10, 20, 20, 20,
Yeah,
20.
yeah. So we do have 90 minutes together, correct?
Well,
Yeah,
no,
3 hours, I thought.
we have 3 hours, and then you have 2 1-hour sessions.
Hold on.
Yeah,
We can
let's keep a margin of error for.
Yeah, it's I'm very interested about the objective diagnostics, and I don't want that to get shortchanged. I mean, next year's planning, we could probably, if you want to cut that down to a half hour. But
So it's 8 to 1. It's 8 to 1. Wow.
I don't know what the time. It says 8 to 1 there. That's 5 hours.
But it is 8 hours, but we have lunch, which is probably an hour. It is 8 to 1, including lunch.
Oh, okay. So that's 8 to 12, and then 8 to 1.
Wait, I'm confused.
Well, at least it sounds like at least 4 hours then. If it's 8 to 1.
It's 5 hours.
Well, 5 hours, but we break for an hour for lunch.
So yeah, so I was just putting the times roughly. I didn't even but I'm pretty sure that the times I put in there is accurate, which is 8 to 1. But then she had like a lunch at 12.
Okay. Yeah. So then we have 4 hours. So we have plenty of time.
Yeah, and I think I think we have to count it in breaks. Yeah, but I was just thinking. First of all, the people on the topics with the people leading them, like Jamie, Dr. Micali, Joel, Jackie, do you feel that 20 minutes is good, or it's too much, or it's too little? And can we confirm that you're all going to be there in person, or who's going to be virtual, so we accommodate for that?
I'll be there in person. 20 minutes sounds good to me.
If you need more, we have time. Just want to let you know.
I think that amount of time sounds good as kind of like a lessons learned, as opposed to like going deep into the content itself, which is probably less interesting to everyone. I will say I probably will not be attending, unfortunately. I'll have hopefully a 1-day-old. But Will, Kelly.
Wow, congrats in
Thank you.
advance.
But Will Kelly and Ben Martin, who've been intimately involved, will be there, and they can speak definitely on this issue on our behalf.
And also, I did put 20 minutes intentionally, assuming that we're going to have 10 minutes for discussion, because we don't want this to be like a presentation after presentation after presentation. Rather, give some material for people to think about and then use some time to reflect on and discuss.
Sounds good. It's Will Kelly and Ben Martin. I'm sorry. I'll drop that in the chat.
Will and Ben, yeah.
And this is Jackie. I'll be attending in person as well as Ann Ho from Cipher, and we can do 20 minutes. I do want to give people a quick demo of the site to start, just for orienting folks. Yeah.
Yeah, and again, like Asa said, please feel free to add, factor in additional time for any discussion if you need it.
And Jackie, we could even, if people are interested, we could even use, you can orient people to the site and then use sometime, maybe 10 minutes, to ask people to find 5 phenotypes, and then we do some fun exercise about here's a I can find this for diabetes, I can find this is the OHDSI one, this is the other VA ones, and stuff like that.
Yeah, that sounds good. I'll think about that a little bit more too.
A treasure hunt.
Yes, phenotype hunt.
I think we have a new comparison tool on the site, so you can compare the metadata between definitions. That might be interesting for folks. We get a lot of interest in that.
I'm just looking at your notes. Like Joel, I will confirm I'll be on site in 20 minutes is good. It won't really do it justice, but it'll be a good introduction to what will eventually be a paper out of this.
Do you need more time, Jamie?
I could talk about it forever. You can give me 30. You can give me 30 minutes if you want, because it might spark some discussion. But I can cover it in 30 minutes. But I don't know what will become of the discussion.
Jamie, does your result set by then, would your result set benefit from a human review as a way to support your work or review your work?
It would be. I can go over some of it in advance with anyone who wants to get into the weeds more than 20 or 30 minutes.
All right. Anything else on this topic before we get into the phenotype stability diagnostics?
Yeah, anything else people feel that a topic in general about phenotyping, the community, the science, that people feel you want to bring it into the symposium or the workshop discussion during the symposium?
This isn't a suggestion, it's a question. One of the reasons I'm able to make it today, so I apologize for not making it at all for months. But
we miss you, Andrew. We miss you.
I know. I wish I was able to make it. I'm just seeing so many things about LLMs being used to produce phenotype definitions, or at least the first iteration of a phenotype definition. And I see Joel's going to be covering probabilistic phenotype generation. So there's obviously some overlap there, but LLM specifically as a kind of a tool, I'm probably aware of 5 or 6 different parallel efforts to do something like that. So the question is, do you want to have anything that's sort of like this current state of play in the use of LLMs for that? And the other one is, and this is a little more idiosyncratic to me, I'm involved in all these spaces where we've got unusually rich multimodal data. So deep phenotyping, given the presence of multimodal data in the OHDSI context, is the other question. There's just a lot that we're involved in and seeing other people involved in for that. So whether it's using kind of things from text or from waveform or from images or from other sources that are also a part of the OHDSI ecosystem. So again, I'm not suggesting that, and I'm not going to, I have conflicts, so I won't be able to be at this session during the thing, but I just wanted to show up here and ask if those were on the menu or worth considering.
Yeah, so if anybody wants to set up the agenda for the LLM based phenotyping, introduce the idea or talk about what others are doing, because this work group has not focused on LLM based phenotyping, at least this year, as a stated OKRs, but that's definitely open for next year. And this year we can use the time there to just talk about, like, these are the people who are working on it. Let's collaborate with them. Let's make a plan for it for next year or so on. So definitely open to that. Is anybody willing to talk about it at the symposium over a few minutes?
So Gautam, I think what we can do, so it's Andrew's point, like, well taken. We do need to at least start the discussion 100%. So let's see who, we don't need to put people on the spot right now, but we could, but let's have protected time for LLM. It could be some revision, as you said, of what exactly the state of the science, what are people doing in terms of LLM and phenotyping, kind of a educational session. But we also can talk about a few things that we know already happening in the community with LLM, like Keeper, Anna's work. So we can touch on those. We technically have worked on doing the literature review using LLM and summarizing that as an input to our phenotype. So we can talk about these small pieces, but we can also talk about, like, the bigger picture of where is LLM going and how is it affecting phenotyping. And I think anybody can, well, we can solicit from the entire community, not necessarily from this work group. So we can post on the forum. We can just see who's willing to educate the rest of us in terms of the big picture, and then talk about small pieces. And similar with deep phenotyping, maybe we need to solicit across the community who's willing to educate the rest of us. And I see Hayden, I think, hands up.
Yeah, there was a presentation, I think, a year or two ago that kind of I looked at and thought, wow, this is great. And I've been kind of incorporating this into my work for a long time, but it was really, it was before LLMs, but it was how somebody moves through a healthcare system, and that being an indicator of something we can phenotype with. So we would expect somebody with pneumonia to have certain events happen through that, and there have been some models produced with that aren't LLMs necessarily, but Martijn has had Ethan Steinberg over at the SAW Lab over in Stanford present on the femur models, so models that are trained specifically on electronic health records. And they're mostly predictive right now, but I think there's a lot that is being done in the way of not necessarily LLMs, but models that are trained to look at healthcare records as if healthcare, EHR is the language. So they used OMOP as kind of the, I think that has a huge potential for phenotyping. Just this, we would expect certain things to be happening if someone had pneumonia, for example, or heart disease, for example, or maybe even had both, and how those would interact. So yeah, it's definitely present, but we might want to talk with Martijn about it, because I think he is.
Yeah. So that's
aware.
similar to I think Martijn presents some of that in the somewhere in Asia Pacific. Yeah, but
Hayden, what was the name of those models? Is it femur models?
Yeah, I'll link it.
I just want to know how to spell it.
FEMR.
Okay. If you could send us a link when you can. Oh, great. Oh, Shah. Okay.
I think Jackie and Andrew. Jackie won.
Oh, really quick, I was just gonna say the latest issue of Jamia is actually fully focused on use of LLMs, and there's a few articles that might be of interest, even if like someone, I don't know how you guys usually set this up, but if someone didn't have the bandwidth to like set up a, topics for this session, like there's even like a few articles that might be sort of more having like a journal club session. Again, if no one is able to like lead a session,
Yeah.
that is an idea, but.
That's great. That's great, Jackie. Yeah. So we can take it more of a discussion and have the AMIA you said this month or last month, whatever.
This
yeah,
September
okay, this
issue.
volume
Yeah.
to be a pre-lead, to be a pre-read, and dedicate some time to have a discussion. Andrew?
Just wanted to add emphasis to what Hayden had suggested. I made these comments before. I don't know if they're broadly shared, but I felt like not only our community, but other communities using EHR-based definitions of the components of studies focus so much more on characterization of health states than they do on the characterization of care. And our computable definitions that we call phenotypes almost sound like they're exclusively directed towards health states, like what is the phenotypic expression of whatever all these other things are in terms of health, when really we want computable definitions for all the different study components. And some of the things that are really critical to doing valid research are a really meticulous articulation of all the different components of care rather than a single, we know they got this drug versus that drug or that kind of a thing, right? And that's all of the different preconditions and follow-up and management of identified conditions is complex, and we have a ton of data on it, and there's just so much less attention paid to it. So whether it's care pathways, as Hayden was describing, or just in general, some constellation of typical care elements that are typical, it may not follow, a particular sequence of workup, diagnosis, treatment, branched on whatever triage. But that ability to characterize that well in a reproducible way is just, I think, underappreciated, and some broad effort to address that specifically as a kind of computable definition, maybe getting a different term than a phenotype, just because it's so fraught with this sort of health state implication, is something I just wanted to underline, basically. Apart from LLMs or prediction or anything else, I just think we need kind of much better ready to use tools for getting reproducible definitions of those things in order to do better research. Sorry, it's a bit of a soapbox, but you know me. I show up and stand on a soapbox.
You're welcome. Monica?
Yeah, hi. Sorry, I just joined the discussion a few minutes ago, so I missed out the discussion around the LLM. I've been learning it for a while, and may I understand, like, what exactly are you looking for in terms of LLM, understanding and presentation around that?
Oh, Monica, would you be willing to moderate? Are you going to be on the Are you going to attend the OHDSI Symposium?
Actually, I'm not enrolled at the moment, but I'll take a look at that when that is. But are you able to provide me details around, what the
Yeah, we can. Yeah, we can talk offline. And
I think, Monica, as a follow-up, did you say, I couldn't hear it clearly, did you say that you are working on LLMs for phenotyping, or are you asking how to understand LLMs for phenotyping?
Oh, no, I am actually saying I have been, learning LLM, AI, all of the jargon, creating embeddings, creating, all the tokens and everything, and literally right now exploring with, creating embeddings, creating RAGs, implementation of pipelines, addressing questions out of the web, scraping the web, answering out of it, using, certain file inputs and, producing output question answers only out of, that limited, document space. So I want to understand what's the scope here, just in case if I can help moderate the discussions, I'm happy to consider that. But I really want to understand, before I make an offer, I want to understand, what actually is expectation here.
Okay. Also, I want to have an idea, if we have bandwidth, maybe after the symposium, maybe even before the symposium, we have a subgroup of people who are interested in this topic and talk about maybe some specific idea, maybe literature search, maybe using LLMs to structure a definition, maybe review definitions, or some of those, some component of our set of activities.
Yeah. No, I also think
I'll connect with you offline after this call for sure.
Okay.
Perfect. Okay. And Gautam, I think, I mean, there's a hype right now, but we put the hype aside. We know that LLM does help. Even the simple form of a chat box does help in the whole process or task of phenotyping. So, so I'm coming from there. I think maybe next year planning should include that, whether it's a subgroup or people do like separate and use their separate research and use the work with the work group as a like like as a community to reflect to their progress or help in their progress. But we definitely need to think about something more structured into because we know how we can use this technology for phenotypes.
All right. Monica, you still have your hand raised. Do you have anything to say?
Oh, no, sorry. I'm not very familiar with Teams meeting. I'm still trying to figure out the chat and the hands down. Please bear with me.
No problem. No problem. Okay, so this sounds like a very rich agenda. I think I like the idea of reflecting on OKR, talking about progress, talking about science, and at the same time maybe start a discussion about where the science itself is heading and what we want to focus on next year as part of that, including this things that we didn't do this year, or focus on like LLMs or deep phenotyping or phenotyping of care pathways. All those are very interesting and important, obviously, so we can open a discussion to see how we can integrate in next year's OKR.
For the group activity, you'll have, I assume, like the results, which has those that were picked up on the phenotype. Is there going to be on the other end that those who weren't picked up on the phenotype? I don't know if I'm explaining that right. Like if you're having the group evaluate, like, were these do these fit within the phenotype? Will you have the access or the to those that might have not been picked up by the algorithm?
Yeah, we're talking about the objective diagnostics.
Yeah.
Right. So maybe that's a great segue to the next topic. But is that, Gautam, what you wanted to go into the next?
Yeah,
next
I think
topic, or
that's right. That's right. So I want to talk about the objective diagnostics, and I think Hayden, your what you're suggesting, I think, is how to make it interactive. Like, how do we bring content forward for a group collaboration? And that is still not a solved problem. And I'll show you what we have. We still don't know how to make it available for a group, for them to thumbs up or thumbs down, for example, to say this is agree with it or do not agree with it for this reason. So we don't have a tool for that. So there's an opportunity to contribute for that, for sure. What I have here on the screen is some of the work that Aza and I and Patrick and Martijn have been working on. This is the Phenotype Stability Diagnostics. And this just is the RStudio session on my computer that codes it. And we are working on a set of cohort definitions that has been built for the designated medical events. Designated medical events are medical events that have been flagged by the European medical agencies as if detected among people exposed to a drug is highly suspicious of drug related. So these things include events like Stevens-Johnson syndrome or acute liver failure, which could be drug-induced liver injury, or cardiac arrhythmias and so on. So we have cohort definitions for those designated medical events in the OHDSI Phenotype Library. We ran those core definitions on a set of data sources using core diagnostics. And as you all know, core diagnostics has a diagnostic in it, which is called the incidence rate diagnostic. And it visualizes a plot where the time is on the x-axis, that is calendar dates, and the y-axis has the incidence rate. And it is stratified by demographics like gender and age. So we use that information from core diagnostics for the designated medical events cohorts run on multiple data sources in our current framework to review them and make a subjective assessment on whether phenotype is stable or not. What we have done is to use a statistical test to check if it's stable or not. And what the experiment that we want to do is the opinions of people who are trained to interpret incidence rate diagnostics to the statistical test and see if there is a correlation or not. That's the experiment that we want to propose at the OHDSI Symposium. So that's the high level overview. Before we go into the details, any questions, or Aza, do you want to make any additional clarification?
No, but just to be just to be clear, so we conceptually we're thinking of two objective diagnostic. One that is answer the question, is this phenotype stable over time? So given a data source that covers data across multiple years, am I safe to use this phenotypes across this data over all time of observation? Meaning is the phenotype stable across all this time that I have data for, and I'm safe to use it in a study across all time? So this is the first question. Or do I have some weird behavior in certain year that makes the phenotype basically unstable? And so even though I think it's the right phenotype, but look, it's producing all different kind of incidence rate across time, which means suggesting that there's something off happening with time. And of course, knowing the underlying components of the phenotype, that could be because of vocabulary change, because something happened in the data source. Andrew, I'll get to your question. But that's where we made big progress, and that's where we have something right now that Gautam can show you. The second objective diagnostic is also using incidence rate as a proxy of how fit the phenotype is, but it's not answering the question, is the phenotype stable over time in a data source? Rather, it's using the different data source as a source of variation. And if a phenotype is fit for use for all these data sources and it's stable across data sources, then I can expect that the incidence rate produced by a phenotype is consistent across the data sources. Now, if I see that in some data sources, the phenotype is giving me an incidence rate that is very different from all the other data sources, then I can then maybe that is suggestive that this phenotype is not a fit for use for this particular data source. And so currently we've been using this as a visual or like an subjective judgment. Oh, look, the incidence rate here is so low, maybe something happening in this database. So we're trying to take that into a formal statistical test where we compute the global incidence rate across the data sources and then use a statistical test to test if any of these data source is variant of or different than the rest of the data source, and based on that have a fail or pass. We have not yet formalized that test, so we're not talking about it, but by the time of the symposium, we're hoping that we have these data results as well. Andrew?
This is exciting. I'm really eager to use this. We're going to need it in a study for mental health stuff. I think we were pretty sure there's a lot of churn back and forth between different partially overlapping diagnostic criteria for mental health conditions as they look in billing codes and EHRs, which we think is going to be more stable if you get at some of the specific phenotypic features that are common across them. So if you're able to measure things using NLP or the psychometric measures that people are given, that those should be more stable within people and over time than the diagnosis codes, which are sometimes used to justify, I'm giving you this medication or that many. We're just trying stuff out and seeing what you respond to. And so you end up looking like you have a bunch of different diagnoses. But that's mixing within person stability versus kind of stability that shows in a population over time as you use different codes. So I guess my question is, in addition to saying thanks for doing this and I'm excited to use it, is one of the goals to be able to say this type of data within a source? I guess my questions are, there's both a within source possible application of this or possible dimension of it, and a within person possible application and dimension if you expect something to actually be stable over time, if that's the common understanding of the condition. I assume neither of those are the main target, but you could apply them. Is that right? I just wanted to clarify.
100%. The same method would apply. The same statistical method would apply. With the source of the variation, we can change it, but the concept will be the same. Are things stable over time within a person over time or across a group over time? It will be the same kind of models. But yeah, that's a great point. Look how if an event is time variant, just like you have a diagnosis, then you don't have it, then you have it, then you don't have it, or a group of diagnoses, then you can definitely do it within a person history or observation.
Terrific, thanks.
Right. So as this is just a summary, there are 30 cohort definitions in the OHDSI Phenotype Library that corresponds to the designated medical events. Some of these this is the list of phenotype definitions that have failed the diagnostics in at least one data source. So the cohort ID number 207 in this case is acquired pure red cell aplasia, and that has failed in this 3 database IDs, and it's considered to be not stable. Similar is for polymorphic ventricular tachycardia, acute hepatic failure, and there are some events of failure here. Now, I can go into more details about what the statistical method is, but I just want to continue on the high level here. So we tested 30 cohorts on 10 databases with the combinations of 260 combos. In that 260s, there has been at least 8 of the 30. No. Yes. 8 of the 30 cohorts have failed in at least one data source. 7 out of the 10 databases had at least one failure. And the number of combos that failed out of the 260 is 15. So we have a failure rate of 5.8%. How does a failure look like? Here is an example of pure red cell aplasia. I'm plotting them here. So this is considered as stable. I'm going to bring up an unstable here. There. This particular definition is considered to have failed the diagnostics based on the statistical threshold that we have defined. And the number of failures for pure red cell aplasia were 3. There were 3 data sources out of the 10 that had failed. So this is an example of the data source called True1 CCAE, where the where the model found a statistically significant deviation between the expected and the observed.
And Gautam, maybe we can orient to how is that happening from the graph.
Yeah.
So the line, the black line is the actually observed trend over time. So you see on the y-axis are the calendar year, and the x-axis is the calendar year, and the y-axis is the actual incidence computed simply by cohort diagnostics. So it's the true incidence rate of the event. That is the new count, the counts of the new events over people in the database. That's just what if you're familiar with cohort diagnostics, that line is what you get straight out of cohort diagnostic. Across, in this case, from 2001 to 2023. And those are the observed. The dashed line, Kevin, I'll get to you. The dashed line is the expected trend. So this is a trend that is computed out of a Poisson spline model that basically take the incidence rate and then model the rates over time, assuming that there should be some change because we don't expect things to be completely linear. So that's why it's a spline model. So we allow it some degree of freedom. And we actually put 3 different knots. And then based on that, it tells you what the expected trend given the data. And then what the statistical test that we are running is that we are doing a likelihood function that is comparing the array of those expected incidence rate over those years compared to the array of the observed. And when the expected to the observed go above 1.25, that said that there's 25% difference between the expected and the observed, that's when it fails, telling you that there's so much instability of that change over the expected line that we're going to fail that phenotype.
Why do you pick 1.25?
Completely arbitrary.
Okay.
Opinion based. Okay, I see some.
So this is great. So, but I know certain people's opinions of 95% confidence intervals, but I would absolutely love to see 95% confidence intervals around this observed incident rate, because I imagine it is absolutely massive, and then would give me an idea of the underlying numbers that are actually here, and that what all your issue is you don't have a lot of events.
But I think this is why they were talking about doing this across multiple databases, because then, a confidence interval on an incidence rate in one database doesn't really matter. Rather,
but within a database across time, I need an N. I mean, I just need an N. Like, looking at this without an N doesn't really tell me much. I see 6 records with lead left 0 counts found has been removed and 0. I'm already thinking that this is a small number issue.
So hold on. What's the issue? Is that the variation over time is just a small number issue? Is that what you're suggesting?
Yeah, I mean, if I move back farther and farther and farther, if I was a mile away, I would say this looks like this is exactly observed and expected. But as I get closer, I can see, oh, okay, yeah, I can see their peaks and valleys here. But without confidence intervals around this observed,
yeah,
I mean, to me, this just seems like a small number issue.
Yep.
So how many acquired pure red cell aplasias did you have by year? Is there a little table that you could generate of that?
So definitely good feedback. Something that is part of the it's part of the statistical model. The output's available. It's not displayed here. I think your feedback is well received, and we could create a small table at the bottom that displays those numbers, and the display can show the confidence range.
Yeah, but I do believe that the actual variance around those numbers is accounted in the likelihood function. I actually don't think the likelihood function does not assume a certainty around that incidence rate, which that point estimate, and it looks at it actually accounts into variation within each of those point estimate to tell you if that 1.5 was higher or lower than if that ratio is higher or lower than 1.5. Definitely your point well taken on the visual. The visual assume that point estimate is so certain, and it's that point where you actually have a confidence interval around it that is huge, 100%. So we need to add that to the visual. However, the estimate of the ratio, the p-value of that ratio that you see 0.00, definitely take into account that variation. But 100%, it's not represented in the visual.
I think creating this plot where each of those incidence rates on the fluctuating line was actually a meta-analytic incidence rate from multiple databases and then fitting the smoothed curve across all of that would be nice, and it could give you a both phenotype. It would help us get to how a phenotype definition performs across more than just one database, because that's where the real incidence rate variation comes from.
Jamie, that's a very good point. However, it does answer a different question, which is how is the phenotype doing across the different data sources overall? But what the answer, the pass-fail we're trying to create here to generate it is not globally. We're actually answering the question. Is that do we pass this phenotype for all time used in a data source? So people will know, like, you know what, like this is probably particularly the problem you're seeing here in this particular pure cell aplasia is a 2015, 2016 problem. You see that trend going up? It's because of the introduction of the 2015. So we need a person to look at it. It's like, why is that happening? Oh, I see that big slope happening after 2015. Oh, that means if I split the data, the phenotype is stable in this data in prior 2015, after 2015. So the diagnostic is intended to tell you, do not use this phenotype across all use of data in this data source. You need to do something about it if you want to use it. Joel?
Yeah, that's actually going to be my question. Can it actually split it up into periods of time and let you see when it is
when it is
usable?
Yeah, so that would be the second point. But the second iteration of that is that then the model itself can give you hints of where the problem is. Is it just a problem of overall instability, or there's one particular year that is causing like a big change, which by then you would know. Is it a vocabulary problem? Is it a data source problem, and so forth? But yeah,
is the expected basically a smooth curve of the?
It's not it's a Poisson model. So it's a Poisson spline model. So it's not only smooth. It has a smoothing function in it, but it's not purely. It's basically, it's a time trend model. That takes all years in.
And you said 3 knots. Is that
3 knots?
So 3 splines essentially that you use to create it?
Correct.
Yeah. So as part of the model input, we say a maximum of 5 splines, and the spline should not be more than 3, more closer than 3 ticks.
No, Gautam, we went down yesterday. It's 3 splines overall.
Maximum of 3 splines and not more than 3 time intervals, not less than 3 time intervals apart. But it's a natural spline.
There was a big discussion of how many nodes, but yeah. Christopher?
Yeah, I apologize if this is a dumb question, but like I'd expect in many instances like that there would be instability of a phenotype over time, and that's not necessarily a bad thing, as expected based on new guidelines issued, new medications approved by the FDA. Like, so this isn't necessarily like a bad thing, right? It's just something to be aware of to inform how you interpret your data, just so I have that right.
Okay, so there's twofold of this answer. One answer is, yes, we expect some change. That's why we do have those splines, because we don't expect things to stay stable. The incidence rate of a disease doesn't necessarily need to be stable over time, the whole time. There is changes, the coding changes. Sometimes there's a true trend in an increase of a disease. Absolutely right. That's why there is a room of that differences. Sometimes there's a true completely something happened that truly completely changes how we define something. And this is not okay if you're gonna say this is the disease and it's this. in all our studies, we assume that the outcome is the same over years. That is an assumption we make. So if actually that's not true because of these big changes, we need to know that to account for it in the study. So definitely it needs to come out. Now, if the change is small, that's fine. Our studies should be able to account for it. But if it's something big, then you definitely need to know and be aware of it to know if you can use the phenotypes over time or not.
Yeah.
But there's a difference between, natural changes over time, let's say
Yes.
COVID or something causing something, versus, I mean, so you said the assumption is that the incidence rate should be stable over time, but I think it's the incidence rate of the phenotype algorithm should be stable over time. The incidence rate over the true incidence rate
could change.
It could change,
Yeah.
and that doesn't invalidate our phenotype.
No.
Invalidating a phenotype is when the phenotype changes differently from what would have happened normally.
Correct.
Yeah, natural.
All right. Time check. We are at 9:58. Andrew, go ahead.
That's just a really interesting conversation, as much about what people see as the implications of the results as the what's calculated, and some recording of what people see as the options once you discover like a shift that's probably due to a code change or something like that. Do you bifurcate the phenotype definition before and after a certain date in order to maximize capture? Do you say it's just not suitable because there is this shift? That kind of decision making, I don't think we have consensus as a community about. And so as you're socializing the use of this, just capturing kind of what the thinking is and the rationale for it is probably a useful component or opportunity. So, but great stuff. Thanks for doing this.
Really interesting.
So 2 topics. One is, what do you guys think about this topic as a 60-minute plus conversation at the symposium? Second, Hayden and others, anybody willing to help create a system, a tool to do this collaboration where we want to capture people's opinions about a phenotype stability versus that statistical test?
Yeah, I'm just wondering, I don't know. This seems like more than an hour. This is a big thing.
And that's one component. There's another bigger component.
Well, yeah, I mean, that's, this is probably more than an hour just to be able to get our heads around it and look at the different data and things like that. Curious to see. I mean, the DMEs are generally small incidence, low incidence rate events. Be more interested also to see some of the other ones that we could look at, MI or something like that, where it's whether there's differences between, whether it's just sample size that's causing a lot of the problems.
Yep. All right, we are at time. Any last minute comments, Aza?
So nothing. Our next step is to have a better structured agenda, including changing the time and see how we want to run the experiment and how much time we should give it. But we will formalize the agenda more as we get closer.
Yeah, and Monica, please feel free to bring us for further conversation LLMs. Jamie?
If anybody wants to stay on a little bit, I would love to show an introduction to the incident rate correction work that I'm starting to get through, which I'm about to apply to all of the Phenotype February phenotypes that we developed for those 4 conditions. So many of you probably have to go, but if anyone wants to stay on, I'd love to show just a teaser for what's going to happen for what I'll present at the work group.
All right, I need to drop off. Thank you, everybody.
Bye, folks.